Hello, this is the first lecture on vectors, which is chapter 3 in your textbook. We've talked about vectors a little bit, and we're going to talk about them in more detail today. And we're going to learn how to find the magnitude and the direction. We're going to learn how to find components of them. We're going to learn how to add and subtract vectors. We're going to also discuss unit vectors and relative motion. So remember that a scalar is just a number with units. Quantities like mass and time have nothing to do with direction, and in physics we have lots of numbers like that. But we also have numbers that are related to a direction. They have a magnitude, so a numerical value, and a direction. And these quantities are called vectors. So imagine that you wanted to go to the library. How would you get to the library? You're right there in the center of the quad, and you're trying to get to the library. Well, what would you need to know? You would need to know how far it was. Well, that's just the radius of the circle, half a mile. But you would need to know where the library was. So this is an example where, direction is necessary. If you want to go somewhere, you want to get to a certain location, you have to know its direction. So in physics, there are lots of quantities that we have that have a definite size, like 0.5 miles, and a definite direction, like northeast, southeast, north, south, west. So we have to have some way to locate ourselves. We have to have some kind of coordinate system. So the coordinate systems that you're most familiar with is the Cartesian coordinate system of just describing a point in space. So if we describe point P is 3 units on the positive x-axis and 5 units on the y-axis. So in physics, the positive axis, x-axis, is east, and the positive y-axis is north. So you could say that point P is located 3 meters to the east and 5 meters north of the origin in this graph. You guys are used to calling this a point, an xy coordinate of a point. So positive x will be east, negative x will be west, positive y is north, negative y is south, and each quadrant has its own x and y locations. When you're in the first quadrant, you're east and north. In the second quadrant, you're west and north, so a negative x and a positive y. In the third quadrant, you're west, negative x, and south, negative y. And then in the fourth quadrant, you're east, positive x, and south, negative y. So even though you know how far and in which direction it is, you still might not be able to get to the library because there's buildings in the way. So that means that you would have to take an alternate route. So think about that. Think about where the library is. You could walk towards the library at a specific distance at a certain degree heading, northeast, northwest, or you could walk 3 blocks to the west and 3 blocks north, and you would end up in the same place. So vectors are very similar to this example. A vector has a definite magnitude and direction, like 0.5 miles northwest, or a vector can be described using components, x and y components, the x coordinate and the y coordinate of its tip. Note that a vector is also drawn as an arrow, and it points in the direction that it's headed. And this is vector A, and the symbol that we use for vector in math is a little arrow sign over your book will boldface vectors. So all vectors have an x and a y component, which can be found using trig. So once again, just like points, if a vector is in the first quadrant, it has a positive ax and a positive ay. If it's in the second quadrant, it's to the west and north. If it's in the third quadrant, it has a negative x and a negative y. And if it's in the fourth quadrant, it has a positive x and a negative y, east-south coordinate. Component or coordinate, right? So a vector component is analogous to a Cartesian point, xy point. So remember that we can describe it with magnitude and direction. This is most similar to using polar notation. And remember, with polar notation, you have the length from the origin to the point. Okay, so that would be the magnitude of our vector, r. And then we also have its heading. So r is the distance to the point from the origin, which we also call its magnitude. And theta is going to be a polar angle. We're going to define east as 0 degrees. So all our polar headings are going to be measured from the positive x-axis, even though our trig will be finding the reference angle in the triangle. But we will have to adjust to make sure that we're giving our polar heading. Remember that 0 degrees is east, 90 degrees is north, 180 degrees is west, and 270 degrees is south. And we can use trig and Pythagorean theorem. If we know the x and y components, then we can find the hypotenuse and we can find the angle, the magnitude, and the direction. And vice versa, right? If we know r and theta, then we can find x and y using trig. So remember from trig, the acronym SOHCAHTOA. If you look at a right triangle, the angle in question can be the sine, which is just the ratio. The sine of that angle is the ratio of the side opposite to the hypotenuse. Just a ratio. So if sine of the angle is 0.5, that means that the opposite side is half the length of the hypotenuse. Cosine is the ratio of the adjacent side to the hypotenuse. Tan is just the ratio of the opposite to the adjacent side. So once again, if tan was 0.5, then the opposite side would be half of the adjacent side. Excuse me, would be twice. No, it would be half of the adjacent side. And we also have a typo here. Not really, it's not really a typo. Kind of a typo. We have Pythagorean theorem, right? If we know the adjacent side and the opposite side, the x and the y, then we can find the hypotenuse squared. So, what this means is that we can use the trig functions to find the x and the y components, the hypotenuse, which is the magnitude, and the direction, theta. So, for example, if I know r and theta, then r cosine theta will give me my x component, and r sine theta will give my y component. So here's an example. If we had a vector of 1.5 meters at an angle of 25 degrees, so that's the magnitude and the direction of the vector, 1.5 times the cosine of 25 would give you 1.36 meters in the x direction, and 1.5 times the sine of 25 would give you 0.634 meters in the y direction. Here's the kicker. Make sure that your calculator is in degree mode and not radians, because we use degrees in this section of physics, not radians, like you might be using in math if you're taking math at the same time. So just like we can find x and y using cosine and sine, we can also find the hypotenuse and the angle. And the hypotenuse and the angle are found using Pythagorean theorem and tan theta. So tan is opposite over adjacent. So tan of this angle here is going to give me y over x. And so if I want the angle, I have to take the inverse tan of ay over ax. If I want to know the hypotenuse, I know that the r squared is equal to a squared plus y squared. And so r is equal to the square root of ax plus ay. Here are some examples. If I give you the magnitude and the direction, you should be able to use cosine and sine to find the x and y components. So the magnitude is 50 kilometers at 90 degrees. So r cosine theta is 0 on the x-axis and 50 kilometers on the y-axis, which means it's to the north. 100 meters per second at 120 degrees has an x component of negative 50 meters per second, which means it's moving to the west, and 87 meters per second, which means it's moving to the north, because it's a positive y value. 30 newtons at 0 degrees is 30 newtons east. 700 meters per second at 220 degrees would be 700 times the cosine of 220, which is negative 536 meters per second west, and negative 450 meters per second south. So that means that a plane that's traveling at 700 meters per second at a heading of 220 degrees has a horizontal speed of 536 meters per second to the west and a vertical speed of 450 meters per second to the south. We can also go backwards, right? If I know x and y, I can use Pythagorean theorem and tan to calculate r and theta. So to find r, I would just take 50 squared in the first example, plus 50 squared, take the square root of it, and I get 71 kilometers. Tan theta gives me 50 over 50, and tan inverse tan of 1 is 45 degrees. This is in the first quadrant, so I don't have to do any kind of adjusting. That is a polar heading. It's measured from positive x-axis. Negative 20 meters per second and 0 is a vector pointing to the west. 20 meters per second at 180 degrees. Excuse me. Our last example, 0 and negative 70 kilometers, is a vector pointing to the south, 70 kilometers at 270 degrees. And note that in our third example, to find the direction, we've noticed that it's got a negative x and a positive y. That means it's in the fourth quadrant. And when the angle is in the fourth quadrant, we have to subtract the angle that we get with tan off of 360 to make sure that we have a polar heading of 297 degrees. In our next video, we'll talk about how to add and subtract vectors.